Bismillahirrahmanirrahim. Assalamu alaikum. Summer task science 2, page number 86, and the topic is water pressure. And then after that, we will study about gas pressure. What is water pressure? Water pressure means water also have some weight like other liquids, and it exerts pressure due to its distribution of its own weight, which acts in all directions. This pressure increase with increase in height. Whatever I'm saying now, that the water pressure increase with height, so you can see in this diagram, in this activity which you can perform at your homes, you can see that in this container we have three openings, A, B and C, and the container is filled with water, right? From the upper layer of water to opening A, we call it height H1. This height is small. You can see this height is small, so it means the weight of the water is also less there. When the weight will be more, it means less pressure will be less, and that is why you can see clearly that the water pressure is low at opening A. Now coming toward opening B, from the uppermost layer up to opening B, we call it H2, and looking toward this, H2 is more than H1, and you can see clearly that the water pressure is also more in this from this opening. Going toward opening C, and the height from the uppermost layer to opening C, the height is H3, and you can see more water is there, height is more, so that is why the pressure of water is also more at opening C. Pressure of water increase with that, we can say now that pressure of water increases with depth. Pneumatics in gas pressure. What is pneumatics? The study of behavior of gases under pressure is called pneumatics. And as you know about the properties of gas molecules, matter is made up of solid, liquid and gases. You know about solid, that the molecules of solid are packed. There is a strong attraction between those molecules and they cannot move far away from each other. As compared to solid, the molecules or liquid are not that much packed. They are a bit far away from each other, and the force of attraction between them is not that much strong like solid. While in case of gases, the molecules are much away from each other, and they can easily move away from each other. The force of attraction between these molecules is less weak, and that is why the gas molecules are. That is how the gas molecules can move from one place to another place. Now we are coming toward the causes of gas pressure. Looking toward this diagram, we have a container here and the gas molecules are inside. As you know that the gas molecules can easily move from one place to another place, is the force of attraction between these molecules is weak. So when they will move, not only they collide with each other, but they also collide with the wall of the container, and the gas pressure will increase. First main case is this, that they are free to move, that is why the gas pressure increase inside a container. But it also depends upon on two things. One is temperature and another one is quantity. How it depends upon on temperature? Inside the container, if temperature rises, when temperature rises, the molecules will gain kinetic energy, and you know that kinetic energy is due to motion. When kinetic energy will increase, the motion of these molecules will also increase, and they will move away and with more speed, and they will not only collide with more speed with each other, with also with the wall of container, and the result will be more pressure inside. For this I will give you the example of a tube of a bicycle burst if it remain standing in hot summer daylight, And another example I will give you, when you fill a balloon with air and you put that near fire, so it burst. So you think about that, why it burst. Now coming toward another thing on which pressure depends upon, that is quantity. If we fill a container with more gas, so again the molecules, more molecules will be there, more motion will be there, they will collide with each other, and also the more collision will be there with the wall of the container, and result will be increase in pressure. For this, I will give you the example of a tube of a bicycle tire burst if it is filled with more air. Behavior of gas under pressure. Behavior of gas under pressure was explained by Boyles. He was a British scientist in 1662, and he gave this statement that if temperature is kept constant, the volume of gas in a container decreases with increase in pressure, and volume increases with decrease in pressure. What it means? Looking toward the figure, on the right hand side, you can see that the piston is coming down, means the pressure is increasing. So clearly, you can see that volume is decreasing. Moving toward left hand side, so you can see that the piston is up, no pressure is there, means pressure is less, so volume is more in that case. So we can say now that pressure and volume both are inversely proportional to each other. If pressure will increase, volume will decrease. If pressure will decrease, volume will increase, and vice versa. Aerosols. What are aerosols? It is an application of gas pressure. Uh, you know all about mosquito sprays, perfume, inhalers, and we use it on daily basis. So, have you ever think about that? What is the mechanism inside the can? You know, the mosquito spray will be there, perfume will be there, but have you ever think about that? What is the mechanism behind how it work? How when you press the knob, when you press the button, and simply the perfume can come out in no time. So how it come out, which thing help it, what is the mechanism? So I hope if as you know all about the gas pressure now, so you will be easily understand now this, that what is the mechanism inside. So let me explain the part of this can. Looking toward the diagram, we have a can bottle, a container. Inside that you can see the product is there. It can be anything, it can be medicine, it can be spray, it can be anything, right? And with that product, you can see there the propellant gas is there. Propellant gas means pressurized gas, and which help in the movement of fluid. As you know about the behavior of pressurized gas, that how the molecules move in pressurized gas, the movement of the molecule is more. So that is why the propellant gas helps in the movement of fluid. Inside that, you can see inside the can, you can see a tube, hollow tube there, and on the top with the green color, that is a knob. So how it basically work? When the knob is pressed, it exerts pressure inside the bottle, and liquid is sprayed out with the help of propellant gas. Propellant gas is there inside, that is a pressurized gas, and that help in the movement of fluid. So how we can define now an aerosol? So an aerosol is a suspension of tiny liquid particles in a gas enclosed. Look, in a gas enclosed is a fine spray by mean of propellant gas. Suspension of tiny liquid particles means they're talking about product, that the product is enclosed with pressurized gas, and it can come out with the help of propellant gas, which help the in the movement of fluid. Chlorofluorocarbons were used as a propellant, but nowadays it is banned because it depletes ozone layer. So I will give you some work here that you search about that which propellant gas is used in aerosol nowadays. So you search about it, and then let me know. Okay.